In this video, we're going to talk about how to assign oxidation numbers. So an oxidation number is a positive or negative number assigned to an atom to indicate its degree of oxidation or reduction. Generally, a bonded atom's oxidation number is the charge it would have if the electrons in the bond were assigned to the atom of the more electronegative element. This sounds all pretty complicated, but in actuality, oxidation numbers are pretty simple. I'm going to teach you a series of rules to assign these numbers, and once you've assigned the numbers, your job of deciding who was oxidized and who was reduced is going to become pretty easy. Let's learn some of these rules. So rule number 1 is the oxidation number of any uncombined element is 0. So also diatomic elements or diatomic molecules are treated as if they were elements, and they are also have an oxidation number of 0. So here's an example here. So in this equation, I have sodium plus chlorine making sodium chloride. So the uncombined element sodium here is not bonded to any other atom of a different kind, gets an oxidation number of 0. So the way we write oxidation numbers is they kind of look like charges, but instead of being in the kind of upper right-hand corner over here, they are usually written kind of in the middle above the element, like this. Okay, so next I have chlorine, diatomic chlorine. So this is technically a molecule. It's an atom bonded to another atom, but not a different atom. So we treat diatomic elements, diatomic molecules, I should say, as if they're just elements. So that would get a 0 as well for an oxidation number. Okay, rule number 2 is the oxidation number of a monoatomic ion equals its charge. So here I have sodium ion plus chloride ion makes sodium chloride. So now my two reactants are ions. This is a sodium with a +1 charge as an ion. This is chloride with a -1 charge. So in this case, your life is easy. The oxidation numbers are the charges. So this would get a +1, and this would get a 1-. So another thing, and this isn't all too important, but another thing is when we write the charges, now I just wrote a plus for this, but if I wrote the number, I would probably write the number 1 and then a plus. If this was like a group 2 ion, it would be like a 2 and then a plus. But notice how when we write oxidation numbers, we write the symbol plus and then the number. So that's a subtle little difference. If you mix them up, I would never take off for it. But if you're curious, that's how it's done. Okay, so rule number 2 is an ion's oxidation number is its charge. Rule number 3, the oxidation number of oxygen in compounds is -2, except in peroxides, like hydrogen peroxide, where it's -1. So here is water. You would just automatically give that oxygen a -2 oxidation number. In hydrogen peroxide, it would be a -1. Now, there's always some exceptions, and we'll go over a couple more exceptions, but you are rarely, if ever, tested on the exceptions, but some exceptions do exist. So on to rule number, okay, so hydrogen peroxide is -1 because hydrogen has to be +1. That's going to be our next rule here. So if hydrogen's +1 in this peroxide that has 2, the ratio is 1:1 of hydrogen to oxygen. Oxygen has to be -1. We'll get into why in a later rule. So rule number 4 is the oxidation number of hydrogen in compounds is +1. And the exception is in metal hydrides, like sodium hydride, where it is now -1. But generally, if you see hydrogen in a compound when you're assigning oxidation numbers, such as water, you remember rule number 3, oxygen is always -2, and hydrogen is usually always +1. In a metal hydride, because sodium is +1, we'll talk about why later, hydrogen now has to be -1. So the general rule number 4 is that hydrogen is always +1. Now there is some rare exceptions, but like I said, you probably aren't going to be tested on them. Rule number 5, the sum of the oxidation numbers of the atoms in a compound must equal 0. So here's water. We've had this a couple times, and you may have gathered rule number 5 if you were paying close attention. But when we get to water here, we have a couple of rules we need to remember. Oxygen is always -2, and hydrogen is always 1 or +1. So if I add the oxidation numbers of all the elements in this compound, it needs to equal 0. So if I have 2 +1s, let's say +2 on the left half of this molecule, and I don't have a number here, which really means there's one of them, and I have 1, 2, -2 on the right-hand side of this molecule. So a 2 plus and a 2 minus equals 0. Here's another one, calcium hydroxide. So let's fill in what we can, remembering some of our rules. So oxygen is always -2, hydrogen is always +1. And I have upper little parentheses here with a little number 2. So the way this works is I add up the sum of the oxidation numbers in these brackets here, in these parentheses. A 2 minus and a -2 and a +1 is a -1. And I have a little 2 here. So that means I have 2 -1s on the right-hand side of this molecule. So that means the left-hand side of this molecule has to balance it out to equal 0, like rule number 5 says. So that means calcium must be +2. So we can do a little math here to prove that it's 0. So if we have +2 plus 2 -2s, because in each hydroxide I have a -2 and I have 2 of them, so 2 times -2 plus 2 times +1 all add up to equal 0. Or you can just do the math in your head like I did. Okay, rule number 6 is the sum of the oxidation numbers in the formula of a polyatomic ion is equal to its ionic charge. So here's an example here. This is a polyatomic ion nitrate, and it's NO3, and the whole thing has a 1- charge. So instead of the sum of the oxidation numbers equaling 0, now the sum of the oxidation numbers needs to equal 1-. Okay, so our rule is oxygen is always -2, so I have 3 -2s, that's a -6 on the oxygen. So I need to ask myself, what plus a -6 is going to equal -1? And of course that is +5. So here's the math you could do, or you could do it in your head like I did. So 3 -2 is equal to -1, solve for x. So we subtract 6 from both sides, -6 from both sides, and we get a +5. Okay, here's another one. Why don't you pause the video and give this a try and figure out the oxidation number of both elements here to make the polyatomic ion sulfate equal a 2- charge. Okay, so of course we fill in oxygen first. It is a -2, and I have 4 -2s. That's a -8 on the oxygen. So sulfur has to be have an oxidation number that when I add it to a -8, I'll get a 2- charge. So I'll solve for x. 4 times -2 is equal to -2. So that's a -8. I will add -8 to both sides, and that will get me +6. So of course +6 and a -8 will be equal to a -2. Okay, also oxidation numbers are on your periodic table. So we've seen this before, but we haven't actually used it for its actual intended purpose. So in the upper right hand corner on your key here, we see that we have selected oxidation states. So these are all the oxidation states that things can be. So like in that last example where we were doing nitrogen, look at all these oxidation states. You have a lot to pick from here. We did another one with sulfur that has a couple different ones, but sometimes you get lucky and there's only one possible oxidation state. Like let's look at group number 2. Group number 2 is always +2. So if you're assigning oxidation numbers or tasked to assign oxidation numbers, there's some rules that you need to remember to fill things in, like oxygen and hydrogen. But then you can also fill some things in just using your periodic table. Like if you're in group 1, with the exception of hydrogen, it's always +1. There's other examples, like in transition metal over here, silver can only be +1. Boron can only be +3. So if you have that, those types of elements in your problems, you can go ahead and fill those in, and then use rules like rule number 5 or rule number 6 to figure out the rest of the oxidation numbers. So let's do some practice here. Go ahead and pause the video and try these three on your own. These are actually pretty easy. You should be able to do this. So go ahead and give them a try. Okay, so in this first example here, we have an uncombined element, that's sodium. So rule number one, the oxidation number of an uncombined element is always 0. Next, we have chloride, so that's a ion. So rule number 2 is the oxidation number of an ion equals its charge. So that's a -1. Next, we have our first compound here, calcium chloride. So calcium is in group 2, and if you look on group 2, you'll see that it is all +2. So you fill in +2, and then you have to do a little detective work. You need to figure out what chlorine is. If you look at chlorine on your periodic table, it can be lots of different oxidation numbers. So you need to ask yourself, what does chlorine have to be that when I add it to this +2, it will equal 0? And remember, I have 2 chlorines. So whatever its oxidation number is times 2 plus 2 has to equal 0. So of course that's -1. 2 minus 1s is a -2. -2 plus 2 is 0. Okay, in this next series of questions, we have a little bit slightly harder. So go ahead and pause the video and give these a try. Okay, so what these things have in common is they're both polyatomic ions. So remember, the sum of the oxidation numbers when you're done needs to equal the charge. And the charges are given for you, of course, because these are polyatomic ions. They wouldn't be here if they weren't. Okay, so let's do this first one. So first thing we do is fill in oxygen. Oxygen is always -2. And I have 4 of them. So 4 minus 2s is a -8. So I need to ask myself, what does chromium have to be so that when I add it to -8, it's a 2- charge? And that, of course, is +6. Another thing I like to do here is check the periodic table to make sure that chromium can be +6. So if it can't, it means you made a mistake elsewhere in assigning oxidation numbers. Okay, next we have phosphate. So again, oxygen is in the problem, so this makes our life a little easy. So I throw in the -2, and I have 4 of them again. So 4 -2s is a -8. So then I ask myself, what does phosphorus have to be so that when I add it to -8, I get a 3- charge? And that is a +5. +5 plus a -8 is a -3, or 3-. Okay, 2 more, slightly larger. We're up in the difficulty level. Go ahead and pause the video and try these out on your own. And when you're ready, you can watch me explain their oxidation numbers. Okay, so as always, we're going to throw in the -2 on oxygen first. And then we have barium and nitrogen to deal with. So if you look at nitrogen on the periodic table, it can be lots of different things. So that's probably not where I'm going to start. I'm going to figure out that last. So hopefully barium, if you look at group 2 where barium is, you can see that it is only +2. Okay, so now that I know that barium's +2 and oxygen is -2, I can use rule number 5 to figure out what nitrogen must be so that the sum of all of them is 0. Okay, so I need to look ahead a little bit here. So I have 2 nitrates. So when I multiply whatever the sum of nitrate is by 2, it's going to balance out the positive charge on this barium here. So barium is +2. So in my head, I'm thinking, I'm hoping this nitrate is -1, so that when I multiply it by 2, I get a -2. So on the oxygen, I have 3 -2s. That's a -6. So what plus a -6 will be -1? And of course, that's +5. Again, I like to check to make sure nitrogen can be +5 on the periodic table, and it can. So 5 plus a -6 is a -1, times 2 is a -2 on the right-hand side of my molecule here. So that will balance out the left-hand side. That's a +2. So the overall charge is 0. Okay, and then the last one here, let's fill in what we know. Oxygen is -2, and hydrogen is always +1. And now I'm left with nitrogen and sulfur to figure out. Okay, so again, I'm going to look to the fact that I have a bracket here and a little number 2. So that means whatever this ammonium is, that when I multiply it by 2, it's going to balance out what the sulfate is. So if nitrogen is -3, sulfur can be +6. So -3 plus 4 is a +1, times 2 is a +2. And then if I have 4 -2s, that's a -8, plus 6 is a -2. So +2 on the left, -2 on the right. This takes a little bit of work. This is like the only combination of what nitrogen and sulfur can be that would make this whole thing work. So hope you got that one. Okay, so now that we know how to assign oxidation numbers, let's put it all together and what you're going to actually be asked to do. So sometimes on the Regents you might get a question where they just want you to find the oxidation number of a single element in a compound, and you use those rules to do this. But oftentimes you need to assign oxidation numbers to figure out who was oxidized and who was reduced in a chemical reaction. Okay, so let's get started here. So in this equation, let's fill out the easy stuff first. So I have oxygen, and I'm going to put a -2 on this oxygen here. So that means this iodine must be a +5. So if I have 5 -2s, that's a -10 on the right. I need a +10 on the left because rule number 5 says the sum needs to equal 0. So 2 times 5 is 10. 5 times -2 is -10. 10 and -10 is 0. Okay, next on this compound here, I have oxygen, so I'll put in a -2. And then I need to ask myself, what must carbon be to balance it out to make it equal to 0? And that, of course, is a +2. Now, notice I have a coefficient in front. This isn't important at all because this coefficient goes for the carbon and the oxygen. So I can ignore it. I could say I have 5 +2s, that's a +10, but I also have 5 -2s, that's a -10. So rather than thinking about the coefficient and what it would do to the oxidation number sums, because it affects everything equally, you can just ignore it. Okay, next I have I2. So this is technically an uncombined element. It's not bonded to an atom of another kind. So rule number 1 says its oxidation number is 0. And then last, I have carbon dioxide. Oxygen, of course, is -2. I have 4 -2s. So that means this carbon needs to be a +4 to balance it out. +4 and -4 would be 0. Okay, now that I've assigned the oxidation numbers, I can determine who was oxidized and who was reduced. So if we remember our phrase, Leo says Gur, if something lost electrons oxidized, Leo, it is its oxidation number is going to increase, because if I lose negative charges, I'm going to become more positive. So in this example, the carbon goes from a +2 to a +4. So its oxidation number went up. So it was oxidized. And the iodine went from a +5 to a 0. So the only way its oxidation number can get lowered is by gaining electrons. So we remember Gur, gain electrons reduction. So this iodine gained 5 electrons to become something with an oxidation number of 0, which means it was reduced. So in summary here, you need to memorize there's actually 6 rules for assigning oxidation numbers. Remember to check the periodic table for elements that can only have one oxidation number. That's usually going to make your life easier when you're trying to figure out the oxidation numbers for the entire compound. And once you correctly assign redox numbers, you should be able to identify the species that's oxidized and the one that's reduced by remembering your little phrase, Leo says Gur. Remember, electrons are negative, so if I lose negative charges and become oxidized, my oxidation numbers go up. If you gain negative charges and become reduced, if you gain electrons, your oxidation number is going to be reduced or go down. So you can remember that phrase, or you can just think about it as oxidation numbers going up means oxidation, and oxidation numbers reducing or going down is reduction. So this obviously involves a lot of practice. The more you do this, the better you'll get. But this skill is absolutely essential, because if you can't assign oxidation numbers correctly, you can't do any of the other questions that are going to be asked of you in this chapter. So if you're having trouble with this, please ask for help, and if you have any questions, let me know.